Okay, first off, let's review some of the graphing that we learned in our last lesson. If you feel like you're fine doing the graphing, you can go ahead and ignore this section and skip ahead to the title and the objective and start your notes there. But for the rest of you, here's a little review on the graphing of systems of equations. You notice that the two red equations, they're ready, they're set up already in y equals mx plus b. We can go ahead and graph those, but if you look at the green problems in number 2, they're not. These two problems we're going to have to change into y equals mx plus b in order to graph them. So let's go ahead and do that. For the first one, we're going to have to minus 4x on both sides. That's going to give us 2y is equal to negative 4x minus 6. And then we're going to divide everything by 2. And that gives us y equals negative 2x minus 3. And then for the other one, we're going to go ahead and add 4x both sides. Gives us negative 2y equals 4x plus 8. Divide everything by 2. I'm going to write it over here underneath the other one. That gives us y equals 2x plus 4. Oop, and Mr. Garg made a tiny little mistake. Let's bring that negative, 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 and that's going to be a negative 2x plus 4. Alright, let's take a look at these graphs. So you notice that when I graph the red lines, it starts out at 1, and it goes, sorry, my bad, starts at a negative 1, and then it goes up 1, over 2. The other equation starts at positive 3, and it goes down 3 over 2. Notice that that is actually the solution right there. That big dot that I'm making, that spot at 2, 0, that's the answer. For the green dot, for the green lines, those aren't going to cross ever. You notice that the negative 2 in front of the x is in front of both, and that means that they have the same slope. And since they have the same slope, the answer here is no solution. They are never going to cross. Okay, so today I'm going to show you guys how to solve these. Instead of by graphing, we're actually going to use algebra strategies. There's two ways to do this. One is called substitution. The other one's called elimination. Today is just going to be about substitution. This guy right here. We're going to come back to elimination tomorrow. So here's how substitution works. You need to make sure that at least one of the equations says x equals or y equals. In this problem right here, it does. I have y equals. Without that, you cannot substitute. If we didn't have it, maybe we'd have to do something else. But since it says y equals, I can go ahead and I can substitute. So how do I substitute? Well, first off, this y and this y are the same y. They are exactly the same. Whatever number works for one works for the other. Therefore, they're replaceable. Now, since this y is equal to 2x minus 2, and these two y's here and here are the same, I can actually plug that 2x minus 2 into that y spot. Okay, so let's go ahead and do that. 2x plus, and now here comes the spot where the y was, 2x minus 2, see it, plugged it in there, and then equals 6. Go ahead and solve this normally. 4x minus 2 equals 6. Add 2 to both sides, and you get 8. So our x is equal to 2 after you divide by 4. And remember, when we graph, when the lines cross each other, you get a point, an x and a y, and a coordinate. Since I only have an x so far, now I got to use it. So the easiest spot to use it is to plug it back into this first equation. So y is equal to 2 times 2. There's the 2 plugged in, right there, minus 2. So the y is now equal to 4 minus 2. Y is equal to 2. So my final answer is 2, 2. Okay. Let's take a look at one more. So in this situation, I see that there is no equation that says x equals or y equals. Instead, what I have is two that are not really what we call ready. So there's a way we can do this. We can get one ready. Since the bottom one doesn't have any numbers in front of the x and y, I think that's going to be a little bit easier to manipulate. So how about, for sake of showing a little bit of variety, let's make this one say x equals. To make the bottom equation say x equals, I'm going to subtract y to both sides. Now this problem says x equals negative y minus 12. Okay, so now I have an x equals. Now remember what I said. I said that this x and this x are the same x. So therefore, I'm going to take what the x equals, negative y minus 12, and I'm going to plug it into that x right there. Here's what it's going to say when I plug it in. It's going to say 2 times, and now plug in the negative y minus 12, and then rewrite the rest of it, minus 3y equals 6. And see, with an equation with only y's in it, we can actually solve it. So let's go ahead and solve it. Negative 2y minus 24 minus 3y equals 6. Negative 2, negative 3 make negative 5y minus 24 equals 6. Add 24 to both sides. Negative 5y equals 30. And we divide by negative 5, and we get negative 6. There is half of our problem. Now remember what we do? We take that and we plug it into the second equation. So now it's going to say x equals negative, but a negative 6. Notice what I did there. There was a negative in front of the y, so that guy is still there. And then that 6 brings in his own negative as well. Minus 12. So x is equal to 6 minus 12. A negative negative is a positive. So x is equal to negative 6. So our answer is at negative 6, negative 6. There we go. Now, there are ways to get things that don't solve and make nice, easy answers. So let me show you a couple different varieties, things that aren't just normal number answers. We talked about those while graphing. So in the first one, what I'm going to do is I'm going to change the top gun by adding 2x to both sides. Now I have an equation that says y is equal to 2x plus 6. So now these two are my system. Again, we're going to plug in what y is equal to. I'm going to plug that into the y spot there. Now it's going to say 4x minus 2 times 2x plus 6 equals 5. Start to solve it. Distribute the 2. 4x, negative 12. 4x minus 4x. Whoa, 4x minus 4x. That's 0. That's nothing. So what happens here is that the x's, they are gone. They're completely gone. What's left over is a negative 12 equals 5. That doesn't make any sense. And since it doesn't make any sense, then this is no solution. Let's take a look at the other one. So in this one, easiest way is to minus 3x on both sides. Now I have a problem that says negative y is equal to negative 3x plus 4, but I don't like that negative there, so you can go ahead and just do plus, plus, and swipe that guy away and make him negative. There we go. Awesome. So now these two right there, these two are going to be the system now that I changed the top one. Again, we're going to substitute. It says y equals, so I'm going to take what y equals and I'm going to put it into the other y. Here's what it says when I plug them in. Negative 9x plus 3 times 3x minus 4 equals negative 12. Negative 9x, distribute the 3, that's plus 9x, distribute the 3 again to the 4, minus 12 equals negative 12. Again, look at that, negative 9x plus 9x, that's 0. Those are gone. What's left over is a negative 12 equal a negative 12. Unlike the last problem, this makes sense. Negative 12 does equal negative 12. But I've ran out of x's. No x's are left in this problem, so I do not know what x equals. But since this is true, since negative 12 does equal negative 12, this is the situation for infinitely many solutions. There we go. Last situation, let's try one last problem before I let you guys go. So again, one of these has to say x equals or y equals. I think the top one is easier than make it say y equals. Let's minus 3x on both sides. Now it's going to say negative y equals 3x. I don't like it, negative 3x. I don't like it to say negative, so let's times everything by positive 1, and that means positive, positive. And since we don't really need to write those, there we go. So now these two equations are now my system. Again, we take what y is equal to and we plug it into the other y. After plugging it in, this is what it says, 4x plus 3 times 3x equals 26. Now it's going to say 4x plus 9x equals 26. And 13x equals 26. Divide by 13 and I get 2. Now I have an x. Now I can plug it back into the y equals 3x problem because I actually get an x. I don't get two numbers that don't equal each other like the no solution. I don't get two numbers that do equal each other like the infinitely many solutions. Since I actually get an x this time, we've got to go ahead and plug them back in. Y equals 3 times 2. Y equals 6. There's my second half to my answer. So 2 comma 6 is my final answer. So that's the difference. 3 different problems, 3 different answers. This is what you do when you see x equals, when you see two numbers that equal each other but they don't have an x anymore, or when you get two numbers that don't even equal each other and the x's are all gone too. Okay, I hope this helped you out. Leave comments if you have any questions, and I'll try to get back to you guys as soon as possible, and I'll see you in class.